So in this video, I want to go through some examples of choosing a suitable value of x when we know that x lies between each of these bounds. So in the previous video, I described what we're looking for. We're looking for the most number of decimal places or significant figures that the two numbers agree to, and that will be our value for x. So for number one, do they both agree to 4.35, right? So I'm looking at one decimal place along. So rather than looking at three decimal places, I'm looking at two. Do they agree to 2? So 4.35, that's what that one would round to 2 decimal places, and this would round to 4.35. So they agree to 4.35 to 2 decimal places. So that would be my value. How about number 2? Do they agree to 2 decimal places? Well, this would be 4.34 and this would be 4.35, so no, they don't. Do they agree to 1 decimal place? 4.3, 4.3? Yes. So x equals 4.3 would be a suitable value of x, suitable degree of accuracy. How about number 3? Do they agree to 2 decimal places? 4.34, 4.35? So no. Do they agree to 1 decimal place? 4.3, 4.4? No. Do they then agree to the nearest integer? 4 and 4? Yes. So best we can do here is 4. Okay? It seems weird, that one, because we know that the values between 4.341 and 4.351, but they only agree to the nearest integer. So that would be a suitable value for x. Number 4, 4.341, 4.562. Do they round to 2 decimal places? Do they agree to 2 decimal places? 4.34, 4.56, so no. Do they agree to 1 decimal place? 4.3 and 4.6? No. Do they agree to the nearest integer? 4, 5? No. So because the value here is 4 and this one be rounding to 5, right, but it's still less than 5, that means the suitable value for x here would be 0. Okay, so both of these would be rounded down to 0. So essentially, we're saying that there's 0 rounded to the nearest 10. Okay, if this had been 5.341 and 5.562, then we would have rounded up to 10. Okay, but they both round to 0 to the nearest 10. And so that would be the most suitable value for x in that case.